Hello students, so this is lesson 13 practice problems. I'm on page 248. Again, remind you to please do these practice problems first and then come and watch the video for the solutions. So we're going to go and look at this one real quick. It says identify a solution for the system. What they're essentially asking is which one of these points is going to actually make both of these true. Okay. So you can kind of look at these things and kind of like see what's different here. So I got negative plus, negative plus, negative plus, plus negative. Let's look at that one. So I put a 4, negative 3 in here. If I put a 4, negative 3 in here, that's going to be 4 plus 3, right? Minus a negative. So 4 plus 3 is a positive 7. So I know that this doesn't work because they're giving a positive 7 and this equation is supposed to be negative 7. So I know that it's not delta. So these are my possible combinations here. Now if you notice, each one of these solves this backwards. So 5 and a 2. 5 minus 2 is negative 7. So negative 2, 5. That is also a solution for that one. Negative 3, 4. That's another solution for that. Alright, so all of these solve this bottom one. The trick is to go and see if you can go and figure out which one of these works only up in that first one. So we look through here. Negative 5, 2. Negative 4 times negative 5, that's a negative 20. Alright, so it starts out with negative 20 to start out with. And then you add 6. Well, negative 20 plus 6 doesn't get you anywhere close to 23. So that one's out. And we can try negative 3, 4. Negative 3, 4. Negative 3 times negative 4 times negative 3. You're at positive 12. And then 3 times 4, that's another positive 12. So that's 24. So that's close, but no cigar. And if you put in this last one, negative 2, so negative 4 times a negative 2 is 8. And then 3 times 5 is 15. And 8 plus 15 is 23. So we know it's this one right here. Now you can also see this math here, what they did. You can also go through and actually solve for the values that make it true. Alright, so we took this bottom equation, solved for the x, and then took that negative 7 plus y and substituted it back up into here and just solved for the y value. Alright, and so we go through, and you can see the math right here. We collect our y's, we put the numbers on the other side, and so y equals 5, and so that is the only one that matches that as well. Alright. So Lynn is solving the system equation. So here's two equations. He's trying to solve it, which means he's trying to find the place where they intersect. And so let's see what this one's trying to say. She starts by rearranging the second equation to isolate the variable. Alright, did she do it correctly? So she said 6x. And she went, let's see, what did she try to do there? She said she starts by rearranging the second equation to isolate the variable. So she went and took this and tried to solve for the y. Let's see if that's right. So if I've got 3x plus 2y equals 8, and I want to solve for the y variable. Alright, I'm going to put that over here. So I'll get 2y equals negative 3x plus 8. And then I'm going to divide everything by 2. So that becomes a y, a negative 3 halves x, plus 4. And yeah, she looks like she did it right. I mean, y equals 4 minus 1/2 x, 1.5 x, which is negative 3/4. So these two equations are going to be similar. So, yep, she did that part right. And so what did she do? She took the 6x, and then she minus 5. She said that the y is equal to this thing right here. So she substituted that in. It equals 34. Alright, so what did she do? Then she distributed. Alright, I mean, recognize that we're subtracting everything that comes out of this. So 4 times 5 is a negative 20. And 4 times that is a negative 7.5, but I have to subtract that negative, so it should be a plus there. Alright? And when that happens, I should get a positive 1.5, not a negative. Alright? So she made a sign error right here. This should be a positive. Okay? And so that's where the problem is on that one. And then, like I did before, he had error carried forward. Okay? So she said negative 36. She went to here, and she put it in to this equation. And so 1.5 times 36, and that's going to be a positive plus the 4, and so we got 58, and so no, it doesn't work. Now you can go and take these numbers. If you're going to say that this is the true solution, then it should work for both of these. Since we got a sign error, we know it's not going to work. Alright, next one here at the top. It says solve each system of equations. Easiest way for here, take the x equal to 4, substitute it in. So 2 times 4, that's an 8. Minus 4y equals 20. Subtract the 8 to the other side. So you have a minus 4y equals 12, divided by the coefficient of the unknown, which is negative 4. Y equals negative 3. Now if y equals negative 3, and you know that x is 4, then the solution is going to be 4 comma negative 3. That's the solution. That's the point of intersection. All right. And what does that look like? Well, it's going to look something like this. X is equal to 4. Oop, there it is. All right. And it's going to go and intersect at 4 comma negative 3, so the intersection is like down here. And since that's negative, it's going to have a positive slope, so it's going to look something like that. Or so. Look at this one. They already solved it for y, so I can just substitute the y in here. So 2x minus 3, or excuse me, 2x minus 3 times the quantity, 6x plus 11 equals 7. I'm going to distribute, but remember I'm subtracting everything that I get out of here. So it's going to be 3 times 6, which is 18, so minus 18x. 3 times 11 is 33, but I have to subtract it, so it's minus 33. So I have all this. The plus 2 and the minus 18 combined for a negative 16x. And I can move the 33 to the other side, which is what they did here. So negative 16x equals 40. Divide both sides by negative 16. Your x is 2.5. All right. Now, when you have the x, you can just put it right back in here. 2 times negative 2.5. All right, plus 11, you end up with a 4. So your solution here is negative 2.5, comma, negative 4. Tyler and Han are solving a system of equations by substitution. Well, let's see. I got 3. I got 2 3y's right there. I got a couple of 3y's. I can solve each one for 3y's, or I can do some substitution. What can I do? So Han says he wants to. Tyler's first step is isolate x, the first equation. So he took this equation, solve for x, and I guess he wants to substitute in the second one. Han's first step was to isolate the 3y. So, and get this equation right here. So in each case, one student solved for x to get this. One person solved for 3y to get this. And looks like, let's see, x, both a negative, 3y equals that. Both look correct to me. Show that both first steps can be used to solve. Okay. Well, this one solved for x, this one solved for 3y. If I solve for x, I can go and put that right down in here. All right, so 9 times negative 5 minus 3y. And I can solve for that one right there. All right, plus the 3y's right there, and then the 3's are here. We distribute, I get a negative 45. And then distribute again, I get a negative 27y. A plus 3y plus 3, or equals 3. I'm going to keep all the y's on one side and all the numbers on the other side. So I'm going to move that 45 over here by adding it, which gives me a 48. Negative 27 plus 3 is a negative 24. Right? So negative 24y equals 48. Divided by the coefficient of the unknown, y equals negative 2. And if y equals a negative 2, you can now substitute it back into here. All right? So negative 5 minus 3 times a negative 2. That equals negative 5 plus 6, which is a 1. Okay, so we're saying here the solution is 1 comma negative 2. And then we go over here, and we do it the other round, all right? So rather than substituting in for the x's, I'm going to substitute in for 3y. So now I have 9x plus the 3y, we solve for it right here, negative 5 minus x equals 3. All right, since it's adding and there's no real distribution going on here, it just resolves to this. And 9x minus 1x is 8x. And I add 5 to both sides, and I get an 8 on the other side. Divide by 8, the coefficient of the unknown, and I get a 1, just like over here. And now I take that and I substitute it back into here. All right, 3y minus 5 minus x times 1, so that's just a 1, negative 5 minus 1, which is a negative 6. Divide both sides by the coefficient of the unknown, and that gives me a y equal negative 2, which is the same as over here. So we're good. It's both work. Okay, a little bit of a review. The dot plots show the distribution of the length in centimeters of 25 shark teeth for the the extinct species of shark, and the length in centimeters of 25 shark teeth for closely related shark species that's still living. So let's see what we have here. You got a mean of 302 and you got a mean of 2.32, standard deviation of 0.55 and standard deviation of 0.13. Compare the two dot plots. Well, this one has more variation because it has more it has a larger standard deviation. This one has longer teeth. All right, so longer and more variable on this top one. Compare the two dot plots. Species 1 has longer teeth than average, and teeth length are greater variability. True. Species 2 has a shorter teeth on average, but less variability in length. So that's all we're really looking for there. And number 6. Kieran buys supplies for the school's greenhouse. He buys F bags of fertilizer and P packages of soil. He pays $5 for each fertilizer, $2 for each soil, spends a total of $90, and then they give you this relationship right here. 5F plus 2P equals 90. So there's the 2, there's the 5, there's the 90, and F is fertilizer, and P is your packages of soil. All right. If Q solves the equation for P, what would the equation be? So we're going to take this equation, we have to solve for P. All right, we have to subtract 5F from both sides. So you'll have 2P equals 90 minus 5F. And then divide both sides by 2, the coefficient of the unknown. So 90 divided by 2 is 45. And 5 divided by 2 is just 2.5. So that would be Charlie. And number 7. Elena wanted to find the slope and the y-intercept of this graph. She decided to put the equation on the slope-intercept form first. Here's her work. And this is fine. You can always check your work if you want to. I mean, I know that slope is negative a divided by b, which is a negative 25 divided by a negative 20. Well, the negatives cancel. And I know I can take a 5 into each one, so 5 goes into 25 5 times, 5 goes into 24 times, which is the slope that they rain. Ah, very good. It's a good check on this. So they took this equation, and they're going to go and solve it and convert over to y-intercept. So they started by putting the x on the other side, right there. And they divide by the coefficient of the unknown, which is the negative 20. And so what did they get? Well, they got, if they divide both sides by 20, you see here we got negative 20s. If they divide both sides by negative 20, let's see what we got. Let's see. Well, she got a negative 4/5. When we did our first initial, we got 4/5. She made a sign error. What did she do? Negative 20, negative 20, negative 20. When you divide 100 by negative 20, you should get a negative 5. And you divide this by negative 20, you'll get a positive 5/4. All right? That's what you should be getting right there. That's where her sign errors showed up. All right, she concluded the slope is this and this. What's her mistake? She dropped a no minus sign used on right hand side. So that's where she screwed up. What's the slope? 5/2. What's the intercept? 0, -5. And we did the math on that one. Right? Alright. On each one, find the x and y intercepts. Well, now this one, this is in a non-standardized form. Let's look at these things. They didn't write these in standardized form. Y equals -2x plus 10. You're always supposed to put the slope right here and then the y-intercept, the number out here. That's the way it's supposed to be. All right? So that way, if you look at this thing, see I got a +10 and a -2x. The slope is -2. The y-intercept is 0, 10. Now how do we figure 0, 10? I know if it's the y-intercept, it's got to cross somewhere like right here. And I know the x value is 0. I know it is. It has to be to cross this. If that's 0, that means this whole thing goes away, and that's the only number left. So it's always got to be this little second part, so it's 0, 10. All right? That's the intercept. Now, if the other, no, that's the x-intercept. If I want to find the y-intercept, now that value for y is 0, and I got to solve for x. So what do I do? Well, let's just put this on the other side. It becomes 2x equals 10 because I add 2x to both sides. Divide by the coefficient of the unknown, x equals 5. So I know that this point right here is 0, 10. And I know this point here is 5, 0. That's my x and y intercepts. Right? And also, your slope is -2. Let's look at this next one. 4x plus 9, 4y plus 9x equals 18. Again, this is a non-standard. This is wrong. You should be writing it 9x plus 4y equals 18. Now you can start doing the magic on this thing. All right. So here we can just look through this thing. All right. I just rearrange this to put the x in front and the y back on the secondary part. Alright? We can find the slope. Slope is going to be -a divided by b. So that's a -9 divided by 4. So that's what that slope actually is. They're asking for the x and y intercepts. So the x and y intercepts are at 0, some number, and some number, 0. So let's substitute in a 0 for here. That's 0. What number can I put here to get to 18? Well, that becomes 4y equals 18. Divide both sides by 4. Y equals 18/4, but I can take a 2 out of both because they're even. So that's 9/2. So that becomes 9/2. All right. On the other intercept, I end up with a 0 on the x. All right, and so I put in, or excuse me, a 0 on the y, so I just substitute that in. So I get 9x equals 18. Divide both sides by the 9. X equals 2. Boop. There it is. So you got 2, 0 and 0, 9/2. Right there. Okay, this one, at least it's in a standardized form. We can do a lot of work with this one. Okay. So now if you look at this one, you'll notice that it's all odd. Or excuse me, they're all even numbers. All right. If you can reduce these, sometimes that'll help a lot. If I take a 2 out of everything, how many times does 2 go into 6x? Well, it goes in there 3x times. How many times does 2 go into 2y? Well, just 1y. How many times does 2 go into 44? Well, it goes in there 22 times. Right? So these two are equivalent statements. I just took out a factor and hopefully made things a lot easier for us. What's my slope going to be? Well, it's going to be a -3, right? Sign change a divided by b, which is a -1. So my slope is 3. Just did that with some quick manipulations. And I got to find this thing's x and y intercepts. Alright, so let's put a 0 in here. 0 minus some y value equals 22. Well, if negative y equals 22, then y equals a negative 22. Alright? Minus 22. And on this one, I'm going to put a 0 in for the y. So this thing goes away, and I just get 3x equals 22. Divide by the coefficient of the unknown. X equals 22 thirds, which is 7 1/3 or so. There it is. 7 1/3. Okay? And this last one, again, it's kind of in a screwy way of looking at this thing. I mean, you start with 2x equals 4 plus 12y. I don't like the way this thing looks. It looks stupid, and so I'm going to fix it. I'm going to go and take this and move it to the other side by subtracting 12y from both sides. Cancel, cancel. 2x minus 12y equals 4. That's an equivalent statement. You'll notice again that I have even, and even numbers. I can go and just reduce this thing and make my life oh so much easier. How many times does 2 go into 2x? It goes into 1x times. How many times does 2 go into negative 12? Well, minus 6 times. Now how many times does 2 go into 4? 2 times. There, I fixed it. All right. Let's go and look at our intercepts. If I put a 0 in for x, that means negative 6y equals a 2. Divide by the coefficient of the unknown. Y equals 2 divided by a negative 6, which is a negative 1/3. All right, so when x is 0, that was a negative 1/3. So there's your answer right there. The second one, I'm going to put a 0 in for the y, which means that x equals 2, because this thing just goes away, and you're done. Boop. There's your other intercept. All right? Andre is buying snacks for the track and ice cream. He buys A pounds of apricots for $6 a pound, and B pounds dried bananas for $4. Buys a total of 5 pounds of apricots and dried apples, and spends a total of $4.50. Okay, so let's break this down. They're giving us 2 equations, 2 unknowns. Okay, so what do we got here? We're saying that we have B pounds of bananas and A pounds of apricots, but we had a total of 5 pounds. So I know that A plus B equals 5. All right, apricots plus bananas equals 5 pounds. And what else do I know? Well, I got a dollar amount stuff I got to work with. So I know that buys A pounds of apricots for $6 a pound, so 6 times A. And B pounds of dried bananas for 4, so 4 times B. And I'm going to spend a total of $24.50. Okay, so let's look through here and see which ones look like. Let's look at the simple one. A plus B is 5. Nope. Yeah, looks good. No. Nothing there looks good. 6A plus 4B equals 24.5. Yeah, that one looks good. B, that's your solution. 10, here are 2 equations. Okay, so you got equation 1, equation 2, y-intercept form. All right, looking at this, I know that the slope is 3. The y-intercept is at 0, 8, just by looking at it. If x is 0, then y has to be 8. And that's like right there. Well, somewhere up here. That's 4, so 8. Equation, this one right here, standard form. Okay. Without using graphic technology, you find the point that is a solution for equation 1, but not for equation 2. Let's see. Find a point that's a solution for equation 1, but not 2. So in this one we came up with negative 1.5. So if we looked at this, look at the intercepts. All right, let's look at the intercepts. I looked at this one, I said 0, 8. Well, does 0, 8 look on this one? Well, let's see, 2 times 0 is 0. Does negative 8 equal negative 6? No. I'd rather go with 0, 8 personally. It's a solution for one, but not the other. Find a point on the solution for equation 2, but not a solution for equation 1. Well, let's see. How do I find the y on that one? Let's see. What if I put in a 0 for the x? What would y be? So if I put in 0 for the x, 2 times 0 is 0, minus y equals minus 6, y would have to be equal 6. Well, does it work on this one? 0 plus 8, that's 8 equals 6? No. So 0, 6. That's a good one, y-intercept. Look at your y-intercepts in this particular one. Graph the two equations. Your two graphs should look like this, or so. Find the equation that's the solution for both. Right? You can do a simple substitution there. Let's take the 2x minus y minus 6, equals a minus 6. And I'm going to go and substitute in, for that y, I'm going to substitute in this thing. I'm going to put in a 3x plus 8 right there. So what's that going to look like? Well, it'll be a 2x minus, and remember I'm subtracting everything I get out of this, 3x plus 8 equals negative 6. So that's all I did. I just took this little part right here and substituted in right here. That's what I've done. So that's a 2x minus 3x minus 8 equals a negative 6. Let's see, 2x minus 3x, that's a minus 1x, minus 8 equals a negative 6. I'm going to add 8 to both sides. Goes away. Negative x equals, looks like negative 6 plus 8 is a positive 2. So x equals a negative 2. Alright, let's see if that works. Did I make a mistake? Alright, and so for this last one, we're going to find a solution. Alright, if I got to this point where I had a negative 2, I needed to find the y, so I just simply substituted into this first one. I put it in negative 2 right here. 3 times a negative 2, that's a negative 6, plus 8 equals the y, which equals 2. So here's your solution. And always check your work. So let's go through these. If I put a negative 2 into here, 6 times a negative 2 is negative 6. Negative 6 plus 8 is a positive 2. Okay, then that point came out. Let's put it into here. Negative 2 times 3, or excuse me, negative 2 times 2 is a negative 4. And then negative 4 minus 2 is a negative 6. So, yeah, that works just great. So this should actually be negative 2 comma 2 is my solution. Right. And that is all for the solutions, or for the practice problems on number 13. I'll look forward to seeing you at lesson 14.